Hello and welcome, guys. This is for my AP chemistry thugs out there. One of the ideas behind doing a video like this is working out some of the problems that I just don't have the time to do it in class. So this has been just an extra resource material. Hopefully this will be helping you. Today we are looking at the ideal gas law. We are looking at the combination of the ideal gas law and stoichiometry. So here I did a problem this morning with my AP class where we have an example where mercury can be achieved by the following reaction, where we have mercury 2 oxide with some heat, we get mercury liquid and oxygen gas. And the first question was, well, what volume of oxygen gas can be produced from 4.10 grams of mercury 2 oxide at STP, or standard temperature pressure conditions? Well, looking at that, I happen to have the stuff already written up here on the board, so that's going to be a review for those people who are looking at the tape. For those of you that you didn't get to see this part, what we did in lecture, this will be a chance for you to catch up on this. So what do we have? Well, we got mercury 2 oxide, we're adding heat, we get liquid mercury and oxygen gas out of this. Okay, we also have 4.1 grams of this mercury 2 oxide, we got STP conditions, and we have the volume of oxygen. That's what they're asking us about. So looking at that, now we have to settle on what are the other pieces of information that we're going to need. Well, we're going to need the temperature. And since it's standard temperature pressure conditions, temperature at STP is 0 Celsius, but we have to change it to Kelvin. So it's going to be 0 plus 273.15. We have our famous R factor there, and our pressure at standard temperature pressure conditions is 1 atmosphere. So this is the information that we are given about the problem. Now the question comes down to is, how do we go about solving the problem? Well, the reality is, if you don't know how to solve the problem in terms of words, then you're probably not going to be able to do that with numbers. So I went ahead and decided to go ahead. Okay, let's move on. Okay, that's the end of our break bell. And my favorite classes here, they're telling me, they're just cheering me on to do this. Okay, so we need to go, one way to go and solve the problem is maybe write down the steps. Okay, you don't need to do this on the actual exam in May itself, but if it helps you, then I think by all means you should do it. So we have to go from grams of mercury 2 oxide to a volume of oxygen. So there's some steps that have to happen. So we can go from grams of mercury 2 oxide to moles of mercury 2 oxide, moles of mercury 2 oxide to moles of oxygen. Okay, and all this right here, those first two steps, guess what? Stoichiometry. You can't escape it. Okay? Once we have the moles of O2, then we can use the ideal gas law to figure out our volume of O2. So I'm just going to go rapidly, go through here just to show, and I wrote out what we're doing. So from grams to moles of HGO, we need to figure out how many grams there are in a mole of HGO, which we did, 216.59. We took our 4.1 grams, divided it by our grams per mole. Okay, remember this is what they gave us in the problem, and we get 0.019 moles of HGO. Fantastic. Notice I have that in green. Okay, then we go on with the next step. Okay, the next step is moles of HGO, which we got from here, to moles of O2. And again, this is using proportion, okay, which is what we did here, and cross multiply and divide, and we end up getting 0.0095 moles of O2 that was made. Again, I put the answer in green so that you guys can follow along with this. All right. Then the next trick that we did was moles of O2 to a volume of O2. We're done with stoichiometry. For some people, they're saying, phew. Okay. But we also have our, now we need to use our ideal gas law. Okay. PV equals nRT. Okay. So V is equal to nRT divided by P. Okay, so our number of moles, our constant R, the temperature, and the pressure. And guess what? We have all that information. Okay, so, and I plugged it in right here, 0.0095, that's our N, 0.083 RR, 273.15, that's our T, and our 1 atmosphere, which is P, which makes things very easy, and we end up getting 0.215 liters. Yes, woohoo! Notice the smiley face going on around it. Okay, so that was a quick review of the first part here. This is what we have done, and I'm going to take a pause here, and we're going to go for the second part in just a moment.